All right, so we are now talking about the parabola. We've drawn parabolas forever. Um, Anytime you have a quadratic, that's a parabola. So, how do we get a parabola when we're talking about conic sections? Well, if you take a cone and you slice it at a diagonal, you get a parabola. All right. So, a couple neat things about parabolas is that from the focus, if you take a line from the focus to any point on that parabola, and then from that point on the parabola straight down to the directrix, this line is the directrix, these distances will be the same, which is kind of cool. The green dot is the focus, and the focus lives inside the parabola. Parabolas come up a bunch. You've seen them all over the places in bridges and paths of projectiles and, satellite dishes and all of these things. So you see them all over the place. So a couple of interesting pieces of the parabola is we have the vertex, which of course is the starting point or the center for the parabola. Then we have this axis of symmetry or major axis or transverse, whatever you'd like to call it. Axis of symmetry works for a parabola because obviously if you cut it in half along this axis of symmetry, they would line up. Then we have this line called the directrix, and it is perpendicular to your parabola. What's interesting is that the distance between the vertex to the focus and the vertex to the directrix, these are the same distances. And that is why that earlier picture where I said those distances would be the same, that's why that works. So let's go ahead and take this and talk about the equations and how they work. With a parabola, you want to play the game of who's line leader, who's in front. If x squared is line leader, he is the squared term, he is in front. If x squared is in front, you're either going to open up or you're going to open up, you're either going to open up or open down. And the value that actually determines that, whether you open up or down, is the value of p. Fun fact, going back to our picture, the distance from the vertex to the focus, and like I said, from the vertex to the directrix, they're the same value. However, that distance is value p. So that's kind of neat. You can find it from the graph. Or if you're given an equation, we'll talk about that too. If p is positive, you're going to open up. If p is negative, you're going to open down. We did talk about that, the vertex to the focus and the focus to the directrix to the vertex. That distance is p. That's always the same distance. We also need two other points in order to draw the parabola because we need to know how wide to go, right? Or how narrow to go. And those two endpoints are the endpoints of a line called the latus rectum. This is an interesting line. It is 2 points on the parabola that go through the focus. And the distance of this line is the absolute value of 4p. And we say the absolute value because distance is always positive, and p can actually be positive or negative. So, a couple of interesting things with the parabola, and they all kind of center around that value of p. So, let's talk about our equations. Let's talk about how to find p, that distance, that value. Here we have our equation. Remember, if p is positive, you open up. P is negative, you open down. You've got your vertex, your focus, and so on and so forth. So let's take a look at an equation. What I'm noticing real quick is that if I were to write the general formula here on top of my equation, I do not see h and I do not see k. That means that h and k are both 0. The next thing I see is that x is the term that is squared. That is line leader, x squared. Okay, so if x is line leader, x is in front, that means I'm either going to open up or down. But I don't know yet because I don't know the value of p. How do I find the value of P? Take your equation. Write the general equation to match. Okay? I don't have the H here. I don't have the K here because my equation didn't have an H or a K. So write the general equation to match. Then draw a big old circle around the 4P and your value. That is going to be the way you find P. 4P equals 12. Solve. You need to divide by 4. P equals 3. Oh, well, 3 is a positive number. So if P is positive, that's positive, we're going to open up. And we open up why? Because X is line leader. In order to get the value of my focus and my directrix, all I have to do is follow my formulas. It's just a plug and chug. You know H, you know K, you know P. The equation for the focus is H, that's a 0, comma, K, that's a 0, plus P, which is 3. Oh, so my focus is 0, 3. Directrix, Y equals K, that's a 0, minus P, that's a 3. So the equation is going to be Y equals negative 3. Not too bad. Like I said, once you have the values of H and K and P, it's pretty much just plug and chug. Let's take a look if Y is in front. Y squared is line leader. This time, if Y is in front, we're either going to open up left or right. And again, P is the one that is going to determine that. If P is negative, we're going to open up to the left. That makes sense. Negative numbers live to the left. And if P is positive, we're going to open up to the right. That makes sense because positive numbers live to the right. Again, we can talk about that distance from the vertex to the focus, which is the same distance from the vertex to the directrix, and that is the value of P. Again, we have our formulas lovely written out for us. We can see how this works when we are opening up left or right. So let's start simply. Let's start with an equation, and we're going to work with one where I don't have an H or a K again, okay? So we're going to write our general equation here. And writing this down, quickly notice that there is no K and there is no H, which means it's 0 and 0. Y squared is the guy who's in front. That's line leader, which means we're either going to open up left or right. Don't know yet. We're going to figure this out. We're going to take our equation and we're going to write the general equation to match, meaning that if I don't have an H or a K up here, I'm not going to put one down here. Draw a big old circle around your value and 4P. That says 4P equals negative 20. We need to divide that over. Divide the 4 over. So negative 20 divided by 4, that gets me a negative 5. Ooh, okay, so that's negative. Wait a minute. This is negative. Excuse my handwriting. That means I'm going to open up to the left because negative numbers live to the left, and we're talking about Y. Oh, okay. So now I can go ahead and I can figure out some points here. Again, I know H, I know K, I know P. So for my focus, it is H, that's a 0, plus P, negative 5, comma, K is 0. So that just gives me a negative 5, 0. Let's see, the directrix, it's X equals H, 0, minus, be careful, it's minus a negative, okay? So really be careful here because this is going to give you the equation X equals a positive 5, and if we messed up our signs, you'll be off. You always check it by graphing, you'll know if it's wrong. You'll see it, and it'll be in the wrong spot. The directrix is always perpendicular to your parabola. Take a look at this one. This one, we actually have just some things to draw. So let's go ahead and plot out some points here. I've got an 8, 0. There's that one. That says that's my focus. And the directrix is X equals negative 8. So X equals negative 8. Every single point on this vertical line has an x value of negative 8. Okay. Ooh, okay, take a look at this. So the entire distance here is 16. Cut that in half. That gives you a distance of 8. That tells me the vertex or the center is right here. 8 units from the directrix, 8 units from the focus. This also tells me that my parabola is going to open up to the right. Well, why is that? Because the focus lives inside the parabola. So I know where my center is, my vertex. I also know that from the vertex to the focus is a distance of p, and from the vertex to the directrix is a distance of p, and that shows me that p equals 8. My center here is 0, 0. We are opening to the right. Remember, when we open to the left or the right, that means I have a y squared. That's the line leader there. We need 2 more points in order to draw this correctly because we don't actually know how wide or how, narrow to make the curve. So we are going to do that by filling out the points of the lattice rectum endpoints. So let's see, I've got h is 0 plus p was 8, comma, k was 0 minus the absolute value of 2 times p, and p was 8. Okay. 0 plus 8, that gives you 8. 0 minus 2 times 8 is 16. The absolute value of 16 is 16, but then you have to tack on that negative, so negative 16. On the next one, we've got, let's see, h, this is 0 plus 8, comma. Here, I've got a k. Nope, my bad. K is 0 plus the absolute value of 2 times p. P is 8. 0 plus 8. Well, that's just 8. We got a 0 plus 2 times 8 is 16. The absolute value of 16 is 16. Tack on a positive. It's still 16. So basically, way over here and way down here, and I've got to go way out this way. My graph doesn't go up to 16, so you got to imagine with me here, okay? So I've got everything on my graph, and I can actually come up with the equation for this. Remember, we said that y was line leader. So it's y minus k, quantity squared, 4p, x minus h. H and k are 0. So really I've got y squared equals 4 times, well, p was 8. And I have x because I didn't have an h, right? That was a 0. So 4 times 8 just gives you 32. So I have y squared equals 32x, and that's the equation of this parabola. Let's take a look at another one. Take a look at this one. And again, the very first thing you're going to do is you're going to write out the general form of your parabola underneath. This helps you with signs, it helps you with lining up things, and it helps you to see if you have a value for h and k, all right? Here I do, right? Here I've got a value for h and k. Remember, when you are working on this, basically you take the opposite of the value you see. I see a positive 2 here, right? I see a positive 2 here. Take the opposite. That means h is negative 2. Oops. So I have h is negative 2. Here, again, take the opposite. That means k is negative 2. So my h comma k is a negative 2, negative 2. All right. So I know where my center is. I'm at a negative 2, negative 2, negative 2. There's my center. All right. It's an x squared, which means I'm either going to open up or open down. All right. So let's write some things in. My center is negative 2, 2. So negative 2, negative 2. So it's either an up or down. We don't know yet, right? What we're going to do is we're going to figure out the value of p in order to figure out if it's an up or a down. So I write the general form of my equation. With my equation, I line them up. I take a circle around the 4p in that value. I can see 4p equals 8 divided by 4p equals 2. Ah, this is a positive number. Well, if it's a positive number, it means it opens up. Lovely. I have the value of p. Oh, wait a minute. Now, if I have the value of p and I know I'm opening up, I can automatically tell you. Let's see. From my vertex go 1, 2 units up. From my vertex go 1, 2 units down. That means that my directrix should be here. My focus should be there. Oh, well, let's see if we're right. Okay. The focus, let's see, P is 2. And my H and my K was negative 2, 2. Okay. I forget these things. Okay. So let's fill out our equations and see if we were right. So H is, let's see, I've got a negative 2, comma, negative 2 plus P is 2. So a negative 2, 0. That is where my focus should be. That's exactly where we drew it because we know from the vertex P units in the directrix, in the direction that you are opening, and I knew we were opening up. That means I knew where that was going to be. The directrix, okay. We know that this is going to be K minus P. K is a negative 2 minus 2. So this should be Y equals a negative 4. That's negative 1, negative 2, negative 3. Yes, that's exactly what we had. Perfect. So you can find a lot of these values and check your equations by simply drawing things out and knowing where they need to go. Here is another one, lots of things to draw. It's telling me my center is 3, 1. So there's a center of 3, 1. It's telling me my focus is 3, 5. 3, 5. And it's telling me my directrix is Y equals negative 3. So it's 1, 2, and 3. Okay. If I'm looking at this, I can go ahead and tell you the value of P because from my focus to my vertex, or from my vertex to my directrix, is the distance of P. And if I'm looking here, this looks like P is 4. It's 1, 2, 3, 4, 1, 2, 3, 4. So I get P is 4. I know that the focus lives inside the parabola, which means that this is going to open up. If I am opening up, that means that x squared is the line leader. Okay. Let's see if we can go ahead and figure out some other things here. Let's see if we can figure out the endpoints without using the equations. Okay, we know that the distance of this line, this lattice rectum line, is supposed to be the absolute value of 4p. We know that the value of p is 4. So that means that it's 16. Okay, so that basically tells me that I need to go, think about it, that's the entire distance, right? From one endpoint to the other endpoint, it needs to be this long. The whole thing, which means my focus lives somewhere in the center. So really, I should go 8 in one direction and 8 in the other. That would give me my 16. So let's see. So 1, 2, 3, 4, 5, 6, 7, 8-ish. There we go. That should be like probably 11. Right? If I take where I am on the horizontal, yes, and I add 8 to it, that should get me the 11. All right. And let's go 8 in the other direction. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Same thing here. Where am I? And I've got to get to 8. Okay. This is what I should get. I should get these points when I fill this out. And of course, we'll fill it out to show that it does work. All right, let's take a look. What was H? H was 3 minus 2 times P is 4, comma, K is 1 plus P is 4. So I get a 3 minus 2 times 4 is 8. 3 minus 8 is a negative 5. And a 1 plus 4 is 5. Next, I get an H. What was H? Oh, 3. Plus 2 times P is 4, comma, K, 1 plus 4. So I get a 3 plus 8. That's 11. And a 1 plus 4 is 5. And if you'll check our points, that's exactly what we got. We can actually figure out the equation for this line because we know that it's x minus h squared because x squared is line leader because we're opening up, and y minus k. So I have an x minus 3 squared equals 4 times 4 because that's what p is, y minus 1. So x minus 3 squared equals 16, y minus 1. Last thing we need to talk about with parabolas is completing the square, and this is everybody's favorite thing to do. However, the nice part with parabolas is we only have one term that's squared, so we only have to complete the square on one term, which is lovely. Let's take a look at this one. First thing you do is you say, who is squared? X, which means that everything that doesn't have an x needs to go on that other side. So we're going to do that. Move that negative 4y over. It becomes positive. Move that 12 over. It becomes negative. Now we have to complete the square on the x's, which means we have to figure this value out. B sub x. It means what is the value that is next to the x? The value next to the x here is 12. If I take 12 and I divided it by 2, I got what? 6. And if I take that value and I square it, I get 36. That means I need to add 36 to this side, but also to this side. Because if I don't, I'm not balanced, okay? It does not even. So I've written this all out here. You've got the 12 divided by 2 squared and so forth. Over here, you'll notice these two values they're just numbers, 36 and minus 12. So do the math and you just get 24. Just clean that up. Completing the square. Factors of 36 that add to give you 12, same sign, both positive. Two numbers that multiply give you 36, but add to give you 12, that would be 6, same sign, both positive. So we get x plus 6, x plus 6. On this side, what can you factor out of these two terms? You can factor out a 4, and that leaves you with y plus 6. Well, that's good because this is supposed to be in the form, right? 4p y minus k. Remember that form? That's what we need. Okay, when you have something that is the same exact thing written down twice and multiplied together, write it down one time and put a square on it. That's what we need anyways. So here now is the general form of this parabola. And from here, we can pick out all of our values. We can see that what? H is let's line it up. H is a negative 6. K is a positive 3. And P is a 1. So we can find all of these values once, or after, I should say, after we've completed the square.